Hello, welcome guys. Today we are going to see the first video for MSc Nursing. Till now we are doing for the GNM, but today firstly we are going for the MSc Nursing where we can see the first unit of statistics. Statistics is the subject in MSc Nursing for the research and statistics. It's combined subject. Here we can see the first unit, that is introductory unit, introduction for the MSc Nursing first year. Firstly, we can see the definitions. Statistics is the science of collecting, organizing, presenting, analyzing, and interpreting the data to assist in making more effective decisions. Then the second definition is a body of methods dealing with the collection, description, analysis, and interpretation of information that can be given in numerical form. That are the definitions. Next, we can see the characteristics of statistics, where the first characteristics is statistics are aggregates of facts. Statistics are numerically expressed. It can be numerically expressed. Numerically means the numbers. Statistics are affected by multiplicity of causes. Statistics are according to reasonable standards of accuracy. Statistics are collected in a systematic manner. Statistics are collected for a predetermined purpose. It should be collected for predetermined purpose. Statistics must be comparable to each other. Next, we can see the branches of statistics, where the first one is theoretical statistics, which includes formulas and rules. Second one is descriptive statistics, which includes numerical, graphical, and tabular forms, means numbers, graphs, or tables. Third one is inferential statistics, in which we are drawing conclusions. Then last one is applied statistics, where the application of statistics for policy purpose. Then the next, uses of statistics. It presents facts in a numerical form. It should be used to present the facts in the numerical forms. Numerical forms means in the numbers, tables, graphs, etc. etc. Then the statistics simplifies complex mass of data. Comparisons of data becomes easier. In research, we have to compare the data, where the if you use the statistics, the comparison of data becomes easier for us. Statistics studies relationship among different facts. It should study relationship between different facts. Statistics studies changes in a variable. We should show that terms, so what is variable, what is statistics, all these things we are going to see next. Then the statistics helps forecasting. In the forecasting also statistics helps us. Then the importance of statistics in different fields, where the statistics is important. First one is the business and economics. Second, banks, insurance, sciences. Then the some basic terms in statistics. Here we can see the definitions of everything. First one is observation. Anything that can be measured or observed is called observation. The things we can measure or observe is observation. Then second one is the data. Number of measurements that are collected as a result of observation. Data means what? Number of measurements that are collected as a result of observation. Firstly, we are going to observe, and which things we are going to collect as a result of observation is called data. Then the population. A population is the set of all units of interest in a particular study. And the sample. A sample is a subset of data selected from population. The parameter. A parameter is the value associated with population. Then statistics. A statistic is a value computed from a sample. Which samples we are collecting, from that sample's computed value is a statistic. Then the variable. A variable is a phenomenon that may vary from one individual or object to another. Means it's different from each other. From one to another, it differs. Variable, in its names, its meaning is there. That variable. Vary means different. Then the constant. A quantity which is fixed is called constant. Constant There are meanings in these words only. Constant means a quality which is fixed. It's called constant. Fixed quality. Fixed quantity, sorry. Fixed quantity is called constant. Then the scope of statistic in nursing. Why the statistics is important in nursing and what is the scope of statistics in nursing? First, we can see the anatomy and physiology, where to find out what is normal or healthy in a population and to find limits in normality in variables such as weight and pulse rate. Which variables we are seeing? The weight and pulse rate. To find the limits in normality. Pulse rate. The mean pulse rate is 72 beats per minute. It is the normal pulse rate. But up to what limits it may be normal on either sides of mean has to be established with certain appropriate teaching uses. Here the use of statistics. Then to find the difference between mean and proportion of normal at two different places or in different periods. Then to find correlation between two variables like height and weight can be found. Then second scope in nursing of statistics is medicine. To compare the efficacy of particular drug, operation or line of treatment. For this the percentage curved in the experimental and control groups is compared and difference due to change or is found by applying statistics. So we can compare the efficacy of particular drugs, operation or line of treatment. Is they effective or not? We are giving the treatment to the patient, but it's showing its effect or not. To compare this, we have to use the statistics like we can see the sign and symptoms in the patient, like patient is coughing, after giving medication the cough is reduced. Like this, we are comparing the variables. All this. To find association between two attributes, to identify sign and symptoms of disease. To identify the sign and symptoms of disease also we have to use the statistics. Then the pharmacology, to find out the action of the drug when given to animals and humans to see whether the change produced are due to the drug or by chance. While we are injecting some drugs to the animals and humans to see whether the change produced are due to the drug, that changes are occurring due to the drug or it's taking place by chance. To compare this, we are using statistics. To compare the action of two different drugs or two successive dosages of the same drug. Here also we can use the statistics, like to compare the action of two different drugs. Two different drugs we are injecting to the same person and we are comparing the action of these drugs or two successive dosages of the same drug. To find the relative potency of the new drug with respect to standard drug. The next, community medicine and public health. To test usefulness of sera and vaccines, percentage of attacks and deaths among vaccinated and unvaccinated samples to find whether the difference observed is statistically significant. Where we have to test usefulness of sera and vaccines, percentage of attacks and deaths among who the peoples are vaccinated and who the peoples are not vaccinated, unvaccinated samples, to find whether the difference observed is statistically significant. Then in epidemiological studies, role of causative factors is statistically tested. In the scope of statistics in other fields. Here the scope of statistics in nursing is ends and the scope of statistics in other fields than nursing. First one is social sciences, where the statistics is used for manpower planning, crime rates, to measure the crime rates. It's a numerical form, so statistics is there. Then the income and wealth analysis of society, in studying pricing, production, consumption, investments and profits. Then planning, agriculture, industry, textiles, education, etc. Then the mathematics, extensive use of differentiation algebra, trigonometry, matrix, and in modern business analysis, there also statistics gets used. Statistics now treated as applied mathematics. Then the economics, where we can use as family budgeting, applied in solving economic problems related to production, consumption, distribution of products as per income and wealth related patterns, wages, prices, profits and individual savings, investments, unemployment and poverty, etc. Then the business management, to analyze the trends, to do the market research and analyze product life cycle. Then the marketing policy decisions depends on forecasting, demand analysis, time and motion studies. inventory control, investments, and analysis of consumer data for production and sales. Then the for production in production field, where you can scope of statistics is designs, methods of production, technology selection, quality control mechanisms, product mix. Then the quantities, time schedule for manufacturing and distribution. All these things we have to plan is among the statistics. Then the finance, correlation analysis of profits and dividends, assets and liabilities, analysis of income and expenditure, financial forecast, break-even analysis, investment and risk analysis. Here also the statistics get used. Then the sales, demand analysis, sale forecast. For this also we need statistics. In the personnel, the wage plans, intensive plans, cost of living, labor turnover ratio, employment trends, accidental rates, performance appraisal, etc. And accounting and auditing, analysis of income, expenditure, investments, profits and optimization of production, etc. For this also statistics gets used. Forecasting cost of production and price. These all are the numerical forms, so we have to use the statistics in that. In the other cases, insurance, astronomy, social sciences, medical sciences, psychology, etc. In all the fields, the statistic gets used. Then the types of statistics. Next point is this types of statistics. Statistics broadly classified into two categories. There are only two categories broadly classified. These are broad classifications. Where the first one is descriptive statistics, or we can call is also summary statistics, where the statistics used to describe or summarize data. It often divided into three measurements of frequency, measures of central tendency, and measures of dispersion, where we can see the measure of frequency, measures of central tendency in the next units. It deals with enumeration, organization, and graphical presentation of data. Then next, inferential statistics, or we can call this also sampling statistics, where the statistics that permits inference means conclusions, where results observed in a sample are likely to be reliable. Test of significance for inferential statistics are parametric test and non-parametric tests. Difference between descriptive statistics and inferential statistics. This is IMP question where you can get this question for the final exam also for MS in first year. First we can see the descriptive statistics and inferential statistics, where first point is concerned with the describing the target population. Descriptive statistics is concerned with the describing the target population, where inferential statistics make inferences from the sample and generalize them to the population. Second point is descriptive statistics organize, analyze, and present the data in a meaningful manner, where inferential statistics compares, tests, and predicts future outcomes. Then descriptive statistics final results are shown in form of charts, tables, and graphs, where the inferential statistics final results are the probability scores. Then describe the data which is already known. Descriptive data describes the data which is already known, where the inferential statistics tries to make conclusions about the population that is beyond the data available. Then descriptive statistics tool is used in measures of central tendency and spread of data, where the inferential statistics the tool is used in hypothesis, tests, analysis of variances, etc. The next is data. Data can be defined as collection of facts or information from which conclusions may be drawn. Is known as data. Data means what? For example, data is the sample. We can say this as a sample. Data are measurements or observations that are collected as a source of information, where we can collecting this data for our research also, where we can say it as sample. Data is a set of values or subjects with respect to qualitative or quantitative data. We use data to be able to gather information for references or analysis. Then types of data. First one is quantitative data. Quantitative data consists of values representing counts or measurements. In its their meaning is in their name only. Quantity. Quantity means what? Excuse me. Yes. Okay, sorry for the distribution. I had got the call. Then first, quantitative data. Quantitative data consists of values representing counts or measurements. There are the numbers. Quantitative data are data about numerical variables, also called numerical data. Where the types of quantitative data, there are subtypes in quantitative data. First one is discrete data. Discrete data is one that has clear spaces between values, where the discrete data has clear spaces between values. Discrete data is countable. We can count that data. Where the discrete data usually involves counting a number of items such as the number of books, computer, people, etc. The next one is continuous data. Continuous data is measured. Continuous data can take on any value as it measures. How we means as it is. In continuous data, you can take the values as it is. It is called continuous because it can take the form of counting numerical readings. So it called as continuous. You can take the notes by pausing the video. You have to watch full video to take notes. The second one is qualitative data. Qualitative data is defined as the data that approximates and characterizes our observations or samples. Qualitative data is non-numerical in nature. It's not numbers or nothing. Qualitative data is also called categorical data since this data can be grouped according to categories. Types of qualitative data. With nominal data. Nominal data is a type of data that is used to label variables without providing any quantitative value. There is no values, no numerical data or no numbers, no countable data. Nominal data can be counted but not put in ascending or descending order. We don't sort this data. We can say we can't sort this data because nominal data can be counted but not put in ascending or descending order, means we can't sort this data. Then second type in qualitative data is ordinal data. Ordinal data are the type of data in which the data values follows a nature order, which follows natural order. Ordinal data is data which is placed into some kind of order or scale. The meanings are in the word itself, that ordinal means order. Then you can count and order ordinal data, but it cannot be measured like numerical data. Okay. The next thing is sample and parameter. A parameter is a measure that describes a population. It is usually denoted by Greek letters. This is the definition of parameter. You can note it down. A statistic is a measure that describes a sample. It's also statistic. We can say statistics or we can say sample also. It is usually denoted by Roman letters. Please remember these things. A parameter is measures that describe a population and it is usually denoted by Greek letters. Parameter denoted by Greek letters and sample denoted by Roman letters. Here the parameters and statistic difference where the population means new. You have to find this meaning of this sign. What we can call this sign. Sample means X bar. Population variance. I don't tell this sign. You have to find this sign and comment down the name of this sign. Who will comment the name of this sign? There is a surprise for that person who will tell the right answer in comments. I have surprise for that person. Then the sample variance is S square. Population standard deviation is that sign. You have to comment it down. Then the sample standard deviation is yes. Okay. If you want to take the notes, you can pause the video and take the notes. It's IMP for all of you for MSc Nursing. Then the levels of data and their measurements. First column is data type and second column is level of measurement. In the first column is qualitative data. If the data is qualitative data, there are two measurements, level of measurements. First is nominal level of measurements, second is ordinal level of measurements. And in the quantitative data, there are two subtypes, discrete data and continuous data. In both the discrete and continuous data, there are two levels of measurement. In discrete data, interval and ratio level of measurement, and continuous data, interval and ratio level of measurement. We can see it in detail ahead. Okay. The nominal level of measurement is characterized by the data that consists of names. What I said, that there are meanings itself in the name of the points. Nominal means names, labels or categories only. Here we can see the definition of nominal level of measurement is characterized by data that consists of names, labels or categories only. The data are qualitative and cannot be ranked or ordered. Qualitative data cannot be ranked or ordered. The ordinal level of measurement applies to qualitative data that can be arranged in some order. Ordinal means order, nominal means names, labels and categories, etc. It generally does not make sense to do computations with data at the ordinal level of measurements. The interval level of measurement applies quantitative data in which intervals are meaningful but ratios are not. In interval, the intervals are meaningful but ratios are not meaningful. Data is this level has a true zero point. Here the true zero point of data. You have to tell the true, what is true zero point in comments. I will not tell that things. You say you only don't know the things, but I know it. If you comment down the answers, I will tell it right or not. Or in the second video, next video, we are going to solve the doubt session. You have to comment your doubts. If you watch full video, then only you can listen to me this point. Okay, the ratio level of measurement applies to quantitative data in which both intervals and ratios are meaningful. Data at this level have true zero point. Here the true zero point, true zero point. You have to write it down in comment what is true zero point. Okay. Organization and presentation of data. Next point is one of the most important aspects in any statistical investigation is the manner by which the researcher presents the data. In which manner the researcher is going to present the data is very useful aspect in any statistical investigation. Okay. Then first point is methods of data presentation. First method is textual presentation, where the data are present in the form of text, phrases or paragraphs. In textual presentation, data is present in text, phrases or paragraphs. Common among newspaper reports depicting specifically the salient or silent or important findings. Okay. Next one is the tabular display. Next method of data presentation. The textual presentation method not only used in newspaper reports, it can used in many things, but common in newspaper reports. Depicting specifically the silent and important findings. The tabular display, a more reliable and effective way of showing relationships or comparisons of data through the use of tables. The tables must be accompanied by a short narrative explanation to make the facts clearer and more understandable. Then the third one is the graphical display. The most effective way of presenting data through the use of statistical graphs. You know the graphs, everyone knows graphs. We will see the graphs and everything ahead also. There is a very big unit is this. In statistics, this unit is only bigger. Can easily attract the attention as well as the interest of the reader. If we are having the graphs and tables in our text, in our books, it can attract our attention because it seems like very, means what we can say, it can seem like a very nice, and it will grasp our mind. It can easy to take in your mind. That's why it can attract the attention of as well as the interest of the reader. We get interest, we can, if we see the graphs, pictures and all these things in our text or books. Then types of graphs. First one is the bar graph. Use rectangular bars, the length of which represents the quantity or frequency of each type or category. Then second one is multiple bar graph. Useful when the researcher wants to compare figures on two or more different occurrences. A legend is especially useful in guiding the viewer in analyzing the data. Then third one is the pie chart. We can see it in detail at the last point of our this unit. Used to present quantities that makes up whole. Constructed using percents, and the slices of the pie are drawn in proportion to the different values of each class, item, groups or category. Then fourth one is the line chart, useful in showing trends over a period of time. Tabulation of data. Next point is tabulation of data, how we can tabulate the data. Tabulation means, here is the definition of tabulation. A table is a symmetric arrangement of statistical data in rows and columns. We are presenting our data in rows and column in symmetric arrangement. Okay. Table involves the orderly and systematic presentation of numerical data in a form designed to elucidate the problem under consideration. This definition is given by Professor L.R. Connor. Please remember this definition. This definition is important. It will ask for 2 marks in our final exam. Okay, table in its broadest sense is an orderly arrangement of data in column and rows. This definition is given by Professor M. Blair. The next point is the features of good table. You are going to make the table to represent our statistical data or present our research in a proper way. We have to use the tables. Then what are the features of good table? First one is a title as compatible with the objective of the study. Our title should be compatible with our objective of our study. To facilitate comparisons, we have to make comparisons between studies. Ideal size, we have to make the ideal size of table. It's not like that pages, our page is A4 and our table is A6. It's not good or not a good impression on the guide. Ideal size, stubs, headings, abbreviations, footnote, total, source of data, size of columns, simple, economic and attractive. The table should be simple, economic and attractive. Then the rules for the tabulation. What are the rules of tabulation? The table should suit the size of the paper, as we say. Table should have to suit the size of the paper, and therefore the width of the column should be decided beforehand. Number of columns and rows should neither be too large or too small. It should be equal. As far as possible, figures should be approximate before tabulation. This would reduce unnecessary details. Our figures should be approximate before we start the tabulation. Items should be arranged either in alphabetical, chronological or geographical order or according to size. There are no hard and fast rules for the tabulation of data, but for constructing good table, following general rules should be observed while tabulating statistical data. The subtotal and total items of the table must be written. How many tables in our study, how many, the total and subtotal of that, it should be written. Percentages are given in the tables if necessary. If necessary, you have to give the percentages in table. Ditto mark should not be used in a table because sometimes it creates confusions. While for the reader, for our guide or for our investigator also, it creates confusion. So don't use the ditto marks in our table. Table should be simple and attractive. A table should be logical, well balanced in length and breadth, and the comparable columns should be placed side by side. Light, heavy, thick or double rulings may be used to distinguish sub-columns, main columns and totals. For large data, more than one table should be used. In the parts of an ideal table, first one is the table number. A number must be allotted to the table for identification, particularly when there are many tables in a study. You have to give the numbers to the table to identify particular tables. Then title. The title should explain what is contained in the table. What is contained in table? The title should explain the contents in table. It should be clearer, brief and set in bold type on top of the table. It should also indicate the time and place to which the data refer. Then third one is date. The date of preparation of the table should be given. When the table is prepared, the date should also given. Stubs or row designations. Each row of the table should be given a brief heading. Such designation of rows are called stubs, and the entire columns is called subcolumn. Column headings or captions. Column designation is given on the top of each column to explain to what the figures in the column refer. You have to give column designations in top of the each column. It should be clear and precise. This is called a caption or heading. Columns should be numbered if there are 4 or more columns. Body of the table. The data should be arranged in such a way that any figure can be located easily. Various types of numerical variables should be arranged in ascending order. Then the source. At the bottom of the table, a note should be added indicating the primary and secondary sources from which data have been collected. From which source you have collected the data, it should be denoted at the bottom of the table as a note. Footnotes and references. If any item has not been explained properly, a separate explanatory note should be added at the bottom of the table. Importance of tabulation. Next point is importance of tabulation. Why the tabulation is important? Under tabulation, data is divided into various parts, and for each part, there are totals and subtotals. Therefore, relationship between different parts can be easily known. Since data are arranged in a table with a title and a number, so these can be easily identified and used for the required purpose. Tabulation makes the data brief, therefore it can be easily presented in the form of graphs. Tabulation presents the numerical figures in an attractive form. It looks attractive if there are tables in our study or our thesis. Tabulation makes complex data simple. It makes complicated data as simple. And as a result of this, it becomes easy to understand the data. This form of the presentation of data is helpful in finding mistakes. Tabulation is useful in condensing the collected data. Tabulation makes it easy to analyze the data from tables. Tabulation is very cheap mode of to present the data. It saves time as well as space. Tabulation is a device to summarize the large scattered data so the maximum information may be collected from these tables. Then limitations of tabulation. Tables contain only numerical data. They do not contain details. Qualitative expression is not possible through tables. Tables can be used by experts only to draw conclusions. Everyone can't draw the tables. Common men do not understand them properly. Methods of tabulation. First one is simple tabulation, where the simple tabulation is when the data are tabulated to one characteristic. Then double tabulation, where the double tabulation is when two characteristics of data are tabulated. In simple, one characteristics. In double, two characteristics. In complex tabulation of data that includes more than two characteristics. Then kinds of table. There are three bases of classifying tables according to purpose, where the first one is general purpose tables, where the general purpose tables is the table which is of general use. It does not serve any specific purpose or any specific problem under considerations. Then B, specific purpose table, where the special purpose table is that the table which is prepared of with some specific purpose in mind. Then according to originality, a first one is original table. An original table is that in which data are presented in the same form and manner in which they are collected as it is. Then derived tables. A derived table is that in which data are not presented in the form of manner in which these are collected. Instead, the data are first converted into ratios or percentage and then presented. Then third one is according to construction, in which subtype is simple table. In a simple table, data are presented based on only one characteristics. Then complex tables. In complex table, data are presented according to two or more characteristics simultaneously. Then the double or two-way table. In such a table, variable under study is further subdivided into two groups according to two interrelated characteristics. Then three-way table. In complex table, we are seeing the subtypes double or two-way table, three-way table. In such a table, variable under study is divided according to three interrelated characteristics. And third one is manifold or higher order table. Such tables provide information about a large number of interrelated characteristics in the data set. Then the difference between classification and tabulation. This is for comparison, meaning the classification is the purpose of grouping data into different categories on the basis of nature, behavior, or common characteristics, where the tabulation is the process of summarizing data and presenting it in a compact form by putting data into statistical table. Then order after data collection. In classification, order is after data collection. In tabulation, after classification. Then arrangement, attributes and variables in classification, columns and rows in tabulation. Then purpose is to analyze the data. We do classification to analyze the data. We do tabulation to present the data. Then bifurcates data information, where the categories and subcategories in classification and heading and subheading is in tabulation. You can write down the notes by pausing the video. And if you say that you are only reading, that are my own notes, so that if I read only, then also we have to take the notes from it. Then the second last point is frequency distribution, where the data in its original form and structures are called raw data. If the data is in its original form, it's called raw data. When these scores are arranged in either ascending or descending magnitude, then such arrangement is called array. When the data are placed in a system wherein they are organized, then these parts take the nature of data. Then the frequency distribution table, under frequency distribution only. The procedure of organizing data into groups is called a frequency distribution table, FDT. Where the components of FDT, first one is class interval, where these are the number defining the class. Definition of class interval is these are the number of defining the class. Consist of the n number called the class limits, namely the lower limit and upper limit. The second component is class frequency, F, shows the number of observations falling in the class. Then class boundaries, these are the so-called two class limits. Classified as lower class boundaries. Lower class boundaries is defined as the middle value of the lower class limit of the class and the upper class limit of the preceding class. And the upper class boundaries, UCB, is defined as the middle value between the upper class limit of the class and the lower limit of the next class. Then the class size, the difference between two consecutive upper limits or two consecutive lower limits. The class mark, midpoint or the middle value of a class interval. Then the cumulative frequency shows the accumulated frequencies of successive classes. Then the types of cumulative frequency, there are subtypes in cumulative frequencies. First one is greater than cumulative frequency, shows the number of observation greater than LCB, lower class boundaries. Then the less than cumulative frequency shows the number of observations less than UCB, that is upper class boundaries. Then the steps in constructing FDT, frequency distribution table. If we are constructing the frequency distribution table, what are the steps in that? First step is to determining the number of classes for first approximation. It is suggested to use the Sturge approximation formula, which is k is equal to 1 plus 3.322 log n. K, where the k is approximate number of classes, n is number of cases. Then second step is determine the range, which is R. Range is equal to maximum value minus minimum value. Then determine the approximate class size, C. Class size formula is C is equal to R divided by K. Range divided by approximation. Range divided by approximation. Then fourth step is determine the lowest class interval. This class should include the minimum value in the data set. Fifth step is determine all class limits by adding the class size to the limits of the previous classes. We have to add the class size to limit of the previous classes. Tally the scores or observations falling in each classes. Then graphical and tabular presentation. This is the last point of our unit. It is bigger point, where the graphical and tabular advantages of tabular presentation. It helps to simplify the raw data. Comparisons can be done easily made. It reveals the pattern of distribution of any attribute defects, omissions and errors. Accurate figures are given. It is having a great value to the expert. Then purposes of graphs. To compare two or more number. The comparison is often by bars or different lengths. To express the distribution of individual objects of measurements into different categories. The frequency distribution of numerical categories is usually represented by histogram. These are the types of graphs we are going to see ahead. The distribution of individuals into non-numerical categories can be shown as a bar diagram. The length of bar represents the number of observations in each category. If the frequencies are expressed as percentage totaling 100%, a convenient way is a pie chart. Then we are seeing the last type is types of graphs, where the first one is histogram. This is one of the most popular methods of displaying the frequency distribution. In this type of representation, the given data is plotted in a form of a series of rectangles. There is a series of rectangles one by one, where the height of rectangle is proportional to the respective frequency and the width represents the class interval. The class intervals are marked along the x-axis and the frequencies along the y-axis. Any blank spaces between the rectangle would mean that a category is empty and there are no values in the class interval. If there is a space between these two, if there is a space between these two rectangles, it shows that this category is empty. Okay. A histogram is two-dimensional in which both the length and the width are important. Merits of histogram. It gives the idea about the amount of variability present in the data. It is useful to find out more. Then demerits of histogram. Histogram cannot be drawn for frequency distribution with open-end class. For the open-end class, it cannot be drawn. Histogram is not a convenient method for comparisons, especially the superimposed histogram are usually confusing. The major steps in constructing histogram, where first step is arrange the data in ascending order. Second, find out class interval. Third, prepare the frequency distribution diagram. And fourth and last is draw the histogram by taking class value on x-axis and frequency on y-axis. Then the second is frequency polygon. It is a line chart of frequency distribution in which midpoints of class intervals are plotted are joined by straight line. It is the variation of histogram in which instead of rectangles erect over the intervals, the points are plotted at the midpoint of the tops of the corresponding rectangles in a histogram and the successive points are joined by straight line. Merits of frequency polygon. It can be constructed quickly than histogram. It enables to understand the pattern on the data more clearly than histogram. Demerits of frequency polygon. It cannot give an accurate picture as that given by histogram, because in frequency polygon areas above the various intervals are not exactly proportional to the frequencies. Then C is frequency curve. Third graph is frequency curve. When the total frequency is large and the class intervals are narrow, so the frequency polygon or histogram will approach more and more towards the form of a smooth curve. Such smooth curve is called frequency curve. Remember this definition. Frequency curve is also called as smooth frequency polygon. In this, total area under the curve is equal to the area under the original histogram or polygon. This usually has a single hump or move. Then next is scatter or dot diagram. This is the simplest method of confirming whether there is any relationship between two variables by plotting values on graphs. It is nothing but a visual representation of two variables by points dots on graph. In scatter diagram, one variable is taken on the x-axis and other on the y-axis, and the data is presented in the form of points. It is called as a scatter diagram because it includes scatters of various points. It includes so many points. The scatter diagram gives a general idea about existence of correlation between two variables and types of correlation. It does not give correct numerical value of the correlation as given by correlation coefficient. Then the merits of the scatter diagram. It is a simple method to find out the nature of correlation between two variables. It is not influenced by extreme limits. It is easy to understand. Demerits of Castle diagram, where it doesn't give correct numerical value of correlation. It is unable to give the exact degree of correlation between two variables. It is a subjective method. It cannot be applied to qualitative data. Scatter is the first step in finding out the strength of correlation. Then next is line diagram, where it is the simplest type of diagram. It is used to presenting the frequencies of discrete variables. In this, there are two variables under consideration. Frequencies are taken on x-axis and independent variables on y-axis, and the line segments joins the points. Next is bar diagram. This one dimensional diagram where bars of equal width are drawn, where the width of bars is equal either horizontally or vertically, which represents the frequency of the variables. The width of bars should be uniform throughout the diagram. In this diagram, bars are simply vertical lines where the lengths of the bar is proportional to the corresponding numerical values. In bar diagram, length is important and not the width. The bars should be equally spaced. The bars may be horizontal or vertical. There are four types of bar diagram. The first one is simple bar diagram, where this type of diagram used to represent only one variable by one figure in simple bar diagram. Then divided by diagram, when frequency is divided into different components, then diagrammatic representation is called a divided bar diagram. Third is percentage bar diagram, where the total length of bar corresponds to 200 and the division of the bar corresponds to percentage of different components. Then last type of bar diagram is multiple bar diagram. When comparisons between two or more relative variables has to be made, then this type diagram is essential. Then the next is pie diagram. This type of diagram enables us to show the partitioning to a total into its component parts. It is in the form of circle divided by radial lines into sections, like pizza. It's look like pizza. It is called a pie because the entire diagram looks like a pie and the components resemble slices cut from it. The area of each section is proportional to the size of the figure. It is used to present discrete data such as group, total expenditure, total area under cultivation for different crops, etc. These are the examples which we can use in pie diagram. Then the merits of the graphical representations. It is more attractive representation as compared to figures. It simplifies the numerical complexity. It facilitates easy comparison of data. It is easy to understand even to the common man also. Graphs. Graphs have long lasting impression on mind. It reveals hidden facts which normally cannot be detected from tabular presentation. Quick conclusions can be drawn by graphs. Then the limitations of graphical representations, where it cannot be used to detail studies, but only for comparative tables shows the exact figure while graphs shows overall position. The figures are approximately correct but not exact. It can give only a limited amount of information because it shows approximate values. It cannot be analyzed further. Its utility to an expert is limited. A table can be used to give data on three or more characteristics, but this is not possible in case of graphs because tables have columns and rows. In graphs, these things are not there. That's why graph cannot give the three or more characteristics. Significance of graphs. In biometry, diagrams and graphs have a lot of significance as these are useful to showing the comparisons. Two or more graphs can be drawn on the same graph paper to show the trend variability occurring in the data. Here we can end up with our first unit in MSc Nursing in Statistics, where we had seen the introductory unit. It is big, very much bigger unit in statistics, and while the other units are very much small because this contains formulas and examples, etc. etc. You can take notes from it. These are my own made notes. I had made these notes by my own. That's why I'm reading it only. If you say you are reading only, these are my own notes. That's why if I read only, then also I get understand. And you should also get understand. All these notes are made according to examination and syllabus. That's why these are important. You should pause the video and take the notes from it. Okay. Thank you guys, and don't forget to subscribe, man. Taking this much efforts for providing the knowledge to you. Okay, do subscribe please. Thank you.